Hi everybody, welcome to the last of the videos that you'll see for Unit 4. This is going to go with Section 4.4, which is just titled More with Linear Functions. Basically what we're going to look at are some basic equations that we can write, given some word problems, and do some interpretation off of those. So this will tie together what we've reviewed with slope-intercept form, some standard form, and those sorts of things. So there are, I believe, 7 examples here that we're going to go through. So again, we're going to set up some equations here and answer the questions that are given to us. Some of this is going to also involve just interpreting some basic graphs and those sorts of things. So let's talk about first example here. The linear function y equals 32x gives the number of 4-ounce servings in x gallons of orange juice. I see x gallons of orange juice. That's probably important. How many servings of orange juice will there be in 3 gallons? Well, x tells me the number of gallons of orange juice, and I tell you there are going to be 3 gallons of orange juice served. So if I want to figure out how many servings there are, all I got to do is plug the 3 in for the x. That tells me y is going to equal 96, which means there are 96 4-ounce servings. As we're going through this video here, if you want to try a couple of these to see if you can get the correct answers, so you can get a feel for what we're doing before I just go through and explain it, please be my guest. If not, continue to watch. Second problem here. Maria began a hike at an elevation of 200 feet above sea level. For the next 3 hours, her elevation increased by 250 feet per hour. Write an equation that represents Maria elevation y after hiking x number of hours. So, I tell you what both variables mean. And like any good word problem, it's good to identify the variables and their meanings, so if you have to do some interpreting, you know exactly what you're trying to find. So let's look at the information we have here. She starts her hike at 200 feet above sea level, so she's plus 200 above the sea. Next 3 hours, her elevation's increased to 250 feet per hour. Now this equation is just asking for, it's just asking for a general equation that represents Maria's elevation after hiking a certain amount of hours. So here's what we know. Her elevation is y. So how high she is in the air has to equal the amount of feet she is increasing per hour. So she's climbing at the rate of 250 feet per hour. So 250 feet per hour we would say is 250x, because x is the amount of hours she's hiking. She's already at a height of 200 feet when she started, so we're going to tack on a plus 200. So the equation that we can write to represent this would be y equals 250x plus 200. Now, it's not asking for this part here, but if the follow-up were to be, well, how high in the air is she after hiking for 3 hours? Since hours is x, all I'd have to do is plug that 3 in for the x, do some quick amount of PEMDAS, and we'd figure out that y is equal to 950, and she'd be at an elevation of 950 feet. These next couple of problems here still related to linear functions, but not necessarily looking at equations, interpreting. Instead, we're going to interpret a graph in a table, as you can see here in numbers 3 and 4. So if looking at 3, the graph below represents the number of miles walked by Kevin over a certain number of hours. How many miles had Kevin walked after 2 hours? So the x-axis is dealing with hours walked, so all I have to do here is find 2 on the x-axis, so right here, and line it up with my graph. So we can clearly see that when x is 2, he is at a point where he has walked, you can see the dot there, he has walked 4 miles. So just by reading the graph here, after 2 hours, Kevin has walked 4 miles. So some questions are just that basic, where all you are doing is taking the graph that's there and just lining up the coordinates. If you know your x and your y values, pretty easy to line up. Number 4, the table below shows the prices that a grocer charges for blueberries. The table represents a linear function. So what that means is this table has a pattern to it. So when I say linear function, there's a consistent pattern every single time. It's not the numbers aren't going to jump all over the place. Based on the data in the table, what would be the cost of 7 pints of blueberries? So there's a couple ways you can figure this out. Well, let's look at the table here. At 2 pints, cost is 11. 3 pints, the cost is $16.50. 4 pints, the cost is $22. So What you can do, the long way, if you will, is to say, okay, 2 gets me 11, 3 gets me 1650, 4 gets me 22. Well, let's say I want 5, so I'm going to just extend my table a little bit. If I notice, every time I go through the table, I increase in price. Every time I add a pint, we're adding $5.50 from one to the next to the next. So we can assume if this is a linear function, that pattern's going to continue. So if I get 5 pints, I'd add another $5.50. It'd be a cost of $27.50. Let's say I get a 6 pint of blueberries. Again, I'm going to add another $5.50 to it. It'd be $33. A 7th pint would be adding another $5.50. That would give me a $38.50 as the overall cost. So you can just kind of count up and just count by 5.5, if you will, added each time until you've got 7 pints, and you can figure out the cost. That's one way to do it. So we can say the cost of those 7 pints is $38.50. The other way you can certainly do it is if you recognize, well, 2 times 5.5 is 11, 3 times 5.5 is 1650, 4 times 5.5 is 22. If you realize that in each row you're multiplying by 5.5, then you can just quickly do 7 times 5.5, you get the same answer. So these problems, there's always sometimes, shouldn't say always, but there are a lot of times multiple ways that you can certainly get to them. It's just a matter of what you see and what makes the most sense to you first. So either way, you end up with $38.50 for the cost of 7 pints of blueberries. Table in number 5 here shows the cost of manufacturing 2, 5, 7, and 8 floor tiles. What is the equation for the linear function that gives the cost of manufacturing X floor tiles? So, from our table here, X is going to be the number of tiles just based off of what the question says. Generally, most word problems that deal with money ends up being the Y variable. So, there's a couple ways you can try to figure this out, but given that we haven't really gone back over like how to write equations with just random ordered pairs, and since there is no, shouldn't say no consistency here, but there certainly, it makes it a little bit harder because we're not in a consistent order. We're hopping from 2 to 5 to 7 to 8. We don't see a consistent pattern off the bat necessarily. What we can do is simply take an ordered pair, plug it into the equation, and figure out which one works. So I'm going to take 2, 7 from my table, treat it as an ordered pair. I'm just going to go plug it in and see what works. Now keep in mind, just because it works doesn't mean it works for the whole thing. So we do want to test all 4 to see if we can eliminate all but one choice. So if I do the first one here, that one's definitely not going to work out. I'm going to end up with 7 equals 1. So A is a bad answer. For B, I'm going to do the same thing. Plug in 7 for Y2 for X. I end up with 7 equals 4. Again, that's wrong. So I've eliminated 2 answers right off the bat. Let's look at C. So I get 7 equals 1/2 times 2 plus 3. That again gets me 7 equals 4. So C doesn't work. So we have to assume that it's D, but let's check in and make sure. 7 equals 2 times 2 plus 3. You do some quick math, you do get 7 equals 7, and that does work out. So D is the correct answer there. If you were to go through it using that strategy, and let's say 2 of the equations worked out for that first order pair, that just means you go to the next order pair, plug it into the ones that worked the first time around, and see if you can eliminate other choices, so on and so forth, until you only have one answer left. Number 6, Bottled Water Company uses the graph below to figure out the weight of the water it transports to local businesses by truck. The graph shows the weight of the water based on its volume. So you can see the way the graph is labeled. The x-axis is the amount of volume in gallons, y-axis is the weight in pounds. So the question is asking, what does the point 10,83 represent? So 10,83 is literally right at the top of the graph. So it's not really asking you to do any math with it, it's just asking you to interpret its meaning. So, option A, 10 gallons of water weigh 83 pounds. So, remember, 10 is X, 83 is Y. So the 10 should represent the volume, the amount of gallons. Okay, so 10 gallons. 83 should represent the weight in pounds. Well, A makes perfect sense. The numbers match up with the units. 10 gallons of water weigh 83 pounds. B has the units reversed, and C and D randomly subtract 10 away from the weight for no good reason. So that's why A is the correct answer for number 6. And last but not least here, number 7, Jude charges $45 per hour to install a door frame and uses $16 of wood. The price P in dollars he charges for a door frame that takes H hours to install is P equals 45H plus 16. Nice problem here where the equation is given to you. He charged $106 for one door frame he installed. How many hours did he take to install it? So you've already got the equation, and I tell you how much he charged for one door. Well, what he charges is the price, aka the variable P. So I'm going to take that 106, stick it in for P, and then all I'm doing is solving for H to find out how many hours it took him to install it. So I'm going to subtract 16. So I'll get 90 equals 45H. Divide everything by 45. 2 equals H. Therefore, it took him 2 hours to install it. So that basically wraps up Unit 4, just using some basic linear functions, looking at some word problems here, interpreting some graphs and tables, etc., just using linear functions in a bunch of ways that we've definitely gone through at earlier points in the semester. And certainly you've done in other math classes, but just again, quick review of some basic word problems, just to keep your minds fresh on that. Your assignment that relates to this. So, in IXL, you're going to find very basic word problems, level K S13. This will be the last IXL for Unit 4. And as always, target score of 80 is what you're looking for. And again, please make sure to complete it by the deadline that I've set in the calendar that you can find on Schoology. So, as always, if you have any questions, send me a Schoology message, shoot me an email, or get a hold of me some other way, and I'll be happy to help you out. Thanks for watching, and we'll see you next time.